Hi guys, in this video, you guys going to learn lesson 6.3 conditional probability. Conditional probability is defined as probability of event A happening given that event B has happened. For conditional probability, it always involves with the two events, which is the second event or one of the event will be the condition. The symbol or the notation that we use to represent conditional probability is this. How we read this? It will be probability of event A happen. The straight line is given that event B must happen first. So this will be the event that is known as the condition, and this B must happen first in order for the event A to happen. The formula to get the conditional probability will be probability of intersection between the two events, let's say event A and B, divided by probability of the event for the condition. So if let's say we have probability of C given E, the formula will change to probability of C intersect with event E divided by, it should be dividing by probability of the condition, and for this case the condition is E, so we divide by probability of event E. If the two events are independent, means they can happen, both can happen at the same time, they're just not related to each other. So if they are independent, the intersection between them will become probability of A times probability of B. This is from lesson 6.2. And what happened to the conditional probability formula? For the two independent events, the intersection become PA times PB. This means we can cancel off the probability of B here, and it leaves us only with probability of A. In other words, if the two events are independent, that means whether B happen first or not, it will not be related to A, or it will not be affecting the A because they are independent to each other. Let us look at the example on how we apply the formula. Let's say for this one, we are given probability of A 0.5, probability of B 0.7, and probability of A intersect with B is 0.4. For A, we want to find probability of A given B. By using the conditional probability formula, it will be probability of A given B equals to probability of A intersect with B divided by probability of B. And this will be 0.4 divided by 0.7, 4 over 7. For the B, opposite now, B given A. So the formula changed to probability of B intersect with A divided by probability of A. And here, you must know that when we have A intersect with B, this will be the same as B intersect with A. So here, probability of B intersect with A is still 0.4, and we divide by probability of A 0.5, it is 4 over 5. C, to find the union, this is from lesson 6.2. By using the rule of addition, it will be equals to probability of A plus probability of B minus probability of A intersect with B, and it will be here 0.5 plus 0.7 minus 0.4 equals to 0.8. And that will be on how we use the formula of conditional probability. Next, you will learn on how to construct or how to understand the tree diagram. Tree diagram is used to compute conditional probability and also to find the probability of intersection by using the rule of multiplication in easy and fast way. As you see on the screen now, we have the tree diagram with two layers. Okay, let me just delete this and draw the new one. For the MAT130S level, normally we will have only two events, event 1 and event 2. To create the tree diagram, you must know which events are the first level and which event is the second level. Because in tree diagram, you will have level 1 and level 2. For level 1, level 1 always consists of single probability. For example, level 1 is event A, with the outcome is A and A prime. So the branch that relate from the starting point to the A is probability of A, and this will be probability of A prime. You must know that total probability when you sum up between the branches here is equals to 1. And here, how to know the number of branches needed to be drawn? Number of branch will depend on number of outcome. For example, toss one coin, the outcome is only head or tail. So you only have two branch here. But if we have roll a dice, how many we have? We will have 6 branch. 1, 2, 3, 4, 5, 6. Where the outcome we just write as 1, 2, 3, 4, 6. Okay, the outcome we just write as 1, 2, 3, 4, and 6. Okay, number of branch will be depend on how many outcomes do we have for the events. The first level, level 1, always single probability. Now, from level 1, we have to move to level 2. Let's say level 2 is the event B. with the two outcomes. Okay, so B, B prime, B, B prime. Again, the number of branch will be depend on the outcomes for the events. How many outcomes do we have for the events? If 3 outcome, then 3 branch. Level 2, the branch that relate the outcome of level 1 to level 2 actually represent conditional probability. This B only happen given that A must happen first. This B prime only happen given that this A must happen first. Same goes to this. This represents probability of B given that A prime must happen first. And the last branch here represents probability of B prime given that A prime must happen first. You must know level 2 always consists of conditional probability. So we have here level 1, single probability, level 2, conditional probability. Now it comes to the rule of multiplication. By using the rule of multiplication, when you multiply the level 1 and level 2, you will get the intersection. So probability of A multiplied with probability of B given A will give us probability of A intersect with B. Probability of A multiplied probability of B prime given A must happen first, it will give us probability of A intersect with B prime. And this will be probability of A intersect with B, A prime intersect with B. And this is probability of A prime intersect with B prime. The product of level 1 and level 2 will give us the intersection between the two events. I will continue discussing the example on the next video. Thank you.